We have a new looping system to help make it easier for folks with hearing aids to listen to the presentations and to ask questions and to participate. Lisa Zovar, would you like to talk to the folks about that system that you and your crew put in place on Monday?
Greetings. I'm so glad to see you all here tonight. I wanted to let you know that on Monday we put magic into this room. Magic. For people who have hearing loss. Are you hearing well?
Yes.
Excellent. If you've noticed, there's a copper wire that's going around the room and between some of the seats. That's the magic. This is called a hearing loop, and what the system does is it brings the sound of the speaker right to your ears without amplifying any background noise. You can hear, Pat, can you hear? Are you in telecoil? How does it sound?
Great.
Excellent. So, it's a 4-part system, real quick. You have to have an electronic sound source. It goes through a piece of stereo equipment, which sends the sound out to these beautiful copper wires that you see. The copper wires transfer the sound, like Wi-Fi, directly into hearing devices that are fitted with an electronic receiver. If you have hearing aids and you don't know if you have the electronic receiver, please contact your audiologist and find out if your telecoil or T-coil has been activated. You'll be able to participate. The magic about this system is that it brings in all of the high frequencies at the same volume as the low. That's not a normal listening situation, but the high frequencies are where the consonants are. So that's where we get word recognition. That's what the loop does. It brings all those high frequencies up to where your hearing devices can adjust. What this actually does is it allows us to participate again, us, the hard of hearing. We can actually enjoy a lecture instead of walking out and saying, what did they say? What did they say? Yeah, exactly. I'm already getting head nods. So that's the story. If you want to use the system, if you have a hard time hearing and you don't have your own hearing devices, we have a really handsome man in the back who has some headsets that you can use. Does anybody want to hear better? Okay, we're good. We got the people covered who need it. So there is an option for people who don't have telecoils to be able to use the system. I am so glad that the university was able to put this in through the generous donation of one of the people who sometimes attends, and it's just such a huge step to include people with hearing loss, the invisible disability. Thank you. I hope you enjoy it.
So I would like to acknowledge the anonymous donor who made this possible. Thank you, anonymous donor. Some of you remember on December 17th, Ruth Lutovsky was here to talk about cochlear implants, and that's where this all began. And I'd also like to acknowledge my colleagues here at the Biotech Center, Richard Kuhnert, Glenn Locke, and Charles Konzinski. And they're the ones that really helped make this go over the months when we ran into difficulties and came up with the option of having the coils on the carpet. There are other rooms at the UW-Madison that have hearing assistance, but this is the first one that's using this loop technology, and I hope... Yeah, that was Lisa. Yeah. I think she's applauding in part because she realizes how convenient this one is, how well it works. So let's move on with the regular stuff. Next week, Randall Davidson will be here from UW-Oshkosh talking about a century of radio in Wisconsin. In 2 weeks, Dolly Ledeen will be here from WisScience talking about adult role models in science. On October 5th, Tim Smeating from the La Follette School of Public Affairs will be here to talk about gaps and intergenerational mobility, the importance of an even start. And as I believe it was Crosby, Stills, Nash and Young that sang, "Choose your parents well." On October 12th, current research on Wisconsin's geology by Ken Bradbury, who's the director of the Wisconsin Geological and Natural History Survey. That week is also the week of National Geology Week, so that's great to have the confluence there. And on October 19th, Paul Koch from the Plant Pathology Department will be here to talk about urban pesticides and turf grass. So we've got the line up through the next month and a half. All right, and let me turn this off. And is that still working okay?
Yes.
Okay. So I think I'm ready to go. Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for UW Extension, Cooperative Extension, and on behalf of those folks and our other co-organizers, Wisconsin Public Television, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight it's my pleasure to introduce to you John Penry, who's here with the Department of Dairy Science. He was born in Melbourne, Victoria in Australia. He went to Xavier School in Melbourne and then got his Doctor of Veterinary Medicine at Melbourne University. Then spent 21 years at Camperdown in Victoria in practice as a DVM. He also went back during that time to get a master's degree in dairy production at Melbourne University. For the last 3 years, he's been here at the University of Wisconsin-Madison getting his PhD. Today, he's going to talk with us about dairy in Oz and dairy here in Wisconsin. He'll be talking about the science of dairy milk harvesting, an Australian perspective, alongside UW research. If you've never been to Australia, I highly recommend it. It should be on everybody's dairy bucket list. Please join me in welcoming John Penry to Wednesday Night at the Lab.
Thank you very much, Tom. So folks, in the Wisconsin dialect, good evening. Thank you very much for coming. Sorry, Wisconsin. In the slightly roguish Australian slang, though, I feel it's on my duty to say just simply to you, g'day, how you going? And you would reply, very well, thank you very much. So folks, tonight we're going to take a three-part wander. It'll be a pretty simple story, lots and lots of photographs, a couple of wayward tales, partly in Australia, partly in Wisconsin, and right at the end we'll see where these two things clash. But I want to start off by just showing you what I think are the two best examples of taking a mechanical process and combining it with an animal production system. So this is the opening gambit for this evening. On the left-hand side we have a milking machine from 1922. On the right-hand side, we have a shearing handpiece, ironically invented in Australia. This is a handpiece, it's a modern handpiece, but the actual basic technology was invented prior to 1900. So both these bits of technology basically date from the late 1890s, early 1900s, and essentially they have remained the same. But here we have probably the best marriage yet of a mechanical process with an animal production system. Now, quite frankly, I don't care much for sheep, so that's the last time you're going to see anything to do with sheep. We're just going to concentrate on the cows for now, okay? Because as we all know, dairy cows are far smarter than sheep. Okay, now, I just want to also start off by saying I have two jobs tonight. The first job is to quench your curiosity, because I'm presuming that you're all here because you're curious. So my job is to make sure that I do a good job of fanning those curiosity flames. The second thing is to give you a little bit of enthusiasm about the dairy industry, and in particular the dairy industry in Australia, and how it intersects with the dairy industry here. My aim is for each of you to be able to, next time you go to a dinner party or the pub and the conversation dies off, you can say, you know what? I know a bit about the dairy industry, and I would like to tell you that right now. That may not happen, but I always live in hope. Now, this image here, folks, is one of the most famous photographs ever taken in our country. It was taken by a fellow called Max Dupain. It's called the Sunbaker. I put it up because I'm sick of putting up images of kangaroos and koalas. And given that most people think that people who come from Australia do nothing but go to the beach or avoid kangaroos and koalas, I thought I would just put this up because this is in part an Australian story. But we do things other than go to the beach. Okay, so I assumed that there were some people in this room who know a little bit about the dairy industry, some people who don't know much at all. So what I thought I would do is just start off with dairy, the basics. And the dairy industry, it's a bit like describing a box factory, because all you've got to do is describe the box, and everything else is just how you arrange them, okay? So here's the dairy industry in very simple terms. Let's say that we have a timeline here on the screen. So January's up this end and December's down that end. And let's say that you have got one dairy heifer, so this is a female dairy animal, and let's say she is 13 or 14 months of age. You have got her pregnant, she's marching through pregnancy, and she gets to the point where she calves. So here she is calving right here. This one needs a bit of assistance. And let's say that this is February. So this animal has calved for the first time in February. She calves. You remove the calf after about 12 hours and you start milking the cow. And in most places in the world, you're milking the cow twice a day. Mechanical milking this is, twice a day, sometimes 3 times a day. But essentially the cow is being milked regularly, much as it would be suckled by the calf. And this goes on for about 300 days. And that's one lactation. And it's that simple. The only other complicating factor, of course, is we want to get her back in calf so that we can repeat this process the next year. So at some point, probably in April or May, you either are using semen or you're using a bull to get her back in calf. So she calves, she starts lactating straight away. In fact, she's building up to lactation just before she calves. You remove the calf to rear it separately. You milk her twice a day or 3 times a day. That maintains the lactation, and you get her back in calf, you get her back pregnant again, and that's it. That's one cow, one lactation, that's the dairy industry. It is literally that simple, because the only other complexity to it, and this is where things get muddled up with a lot of agriculture, the only other complexity to it is essentially how do you feed her, how do you group them for calving, and how do you milk her? That's it. So you've got different permutations and combinations of that, but essentially you've got one animal, one lactation, repeat, repeat, repeat. Okay? So far so good? Excellent. I love a smart crowd. Okay, so here in an American First, I'm going to explain to you the difference between the way animals calve on a dairy farm using nothing more sinister than a solo cup. I've always wanted to try this. Could be dangerous, we'll never know. Let's say, for example, that here is January and here is December. Okay? You have 10 cows. 1, 2, 3, 4. I wonder where the nut is. It's like going to the football. There we are. So, it's very high tech, this presentation. So, January through to December, and on this farm with 10 cows, we are calving a cow most months of the year. January, March, April, August, and so on. So this, my friends, is a year-round calving pattern. Classic for America, classic for the UK, relatively uncommon in Australia, relatively uncommon in New Zealand, but in lots of places, thank you for laughing about New Zealand. I do quite commonly, as it turns out. So this is a year-round calving pattern. Animals are calving all the way through the year. Happy with that? Okay, so let's go to Australia, let's go to New Zealand, and let's go to the southern parts of Australia especially, and let's pick a month. Let's pick let's pick August. So here we are at August, and as it turns out, I have got most of my animals calving in August, September, and October. And that's it. There's nothing calving at this end of the year. They're calving during the spring in the southern hemisphere. So this is called a seasonal calving pattern. Classic for Australia, almost de rigueur for New Zealand. So the cows are calving in a bunch, in a seasonal group. It fits in with the production of pasture. And so that means you're doing other things in batches too. You're doing your joining in a big group, calving in a big group, calf rearing in a big group. Okay? So, seasonal calving pattern. There is one other permutation on the theme, and that is a batch calving or a split calving pattern. So let's say, for example, it suits you to try and milk all the way through the year. So you're going to take these animals from, say, October, and you're going to put them here in March. So March and maybe a little bit of April, I'm calving these animals. No calvings in the middle of the year, and then I get into the spring in the southern hemisphere, and I've got another bigger group calving. So this is called a split or a batch calving system. And that, folks, is it. That's it. Lactation, getting calf, have the calf, start milking, milk for 300 days. Where do I calve in the year is the calving pattern. And the only other thing to worry about is how am I going to get fed and how am I going to get milked? That's it. That's dairying. So, did the solo cups work? Excellent. Well done. Well done to the solo cups anyway. Okay, and just in case they didn't work, here's exactly the same story, except with more attractive Holsteins. Okay, so that's the first part of the story finished. Dairy 101, everyone's got that swedged away. How are you going with the accent, by the way?
What accent?
Okay, what accent? There's a comedian born every minute. Okay, so now we are going to southern Australia. In fact, we're going to the part of the world where I used to live. I know this because this is the clock tower in my hometown. This is Camperdown in Western Victoria. So now let's have a brief look at Victorian dairy, or Australian dairy. This will be one of the few slides with any words or numbers on it. This is to give you a ballpark of what the Australian dairy industry looks like. And in a nutshell, for the recent 2 years, about 1.7 million cows. It's actually dropping at the moment. Average herd 284, but the herd size goes anywhere from about 150 up to about 1,500, encroaching 2,000 in some cases. The average cow produces not a lot by European or Australian or American standards. I've converted it into pounds for you, about 13,000 pounds of milk. It's our third largest rural industry after wheat and sheep, or sorry, wheat and beef, I beg your pardon. And 38% of what we produce, we export overseas, mostly as products like skim milk powder and cheese. Now, if we were in New Zealand, God help us, this number here would be 95%, okay? So that's the guts of it. Here are the numbers for Wisconsin. So this is your state, 1.3 million cows, so slightly less cows than us. 130 is the average, but it's a huge range in Wisconsin as it is in Australia. Twice as much milk per cow being produced per year, and only 14% of what the US produces in dairy goes overseas, and that number is much larger than what it used to be a number of years ago. Okay, and this is just to give you a very brief snapshot of the fact that as we've progressed through the years, from the 90s through until the 2010, this one goes up to, essentially the yellow line is what we have produced that we've exported overseas, the blue line is what we've consumed domestically. So very much a export-driven production system in our country. Okay, so here is Australia. For those of you that are curious, the Australian land mass is almost the same size as the contiguous United States, which means it's bloody big. All of the dairying areas that you can see are marked in red. So I apologise for people who might have trouble with red or green. This isn't my image. As you can see, we have pockets of dairying, mostly in the southern part of the country, but also up along the eastern seaboard, and a little patch over here near Perth, which is Tom's favourite spot, over on the left-hand side. So to give you a sense of the scale, if I was to jump on a commercial airliner and fly from Western Victoria, which is where I come from, this spot down in the lower left-hand side, if I was to fly to the northernmost part where dairying is practiced in our country, I would be sitting on the aircraft for 4 hours. So it's a long way. It's literally like flying from here to Los Angeles. I don't know why you would want to do that, but if you did, that's how long it would take.
Well, so you have to get to Australia via...
Correct. But Dallas is much quicker. So that gives you a sense of the scale. Very disparate pockets of dairying throughout our country. Most of the action, most of the cows live in Victoria, which is the place down on the lower right-hand side. Okay, and here's a pretty typical dairy cow. Every photograph I'm going to show you I took whilst I was in practice. I was in practice for 21 years, and even though I did a reasonable amount of dairy project work, we have national-based projects for animal health in Australia, not regional or state-based. So I was fortunate I got to sort of delve into both worlds. But here's a smattering of the way the production system looks. So here are some animals that are heading up to calving for the first time. I know this because they are being fed very little pasture and mostly hay. Our production system is based predominantly on pasture. We grow most of our pasture from autumn or fall, so it's flipped around. So essentially, if it rains by April, you throw a party. And then we don't grow a lot of grass through the winter months, through June, July and August. And then we have a reasonably large feed surplus in pasture in the spring. And by the time we get to December, the whole country pretty much looks brown. It's literally that simple. And I'll show you a photo in a tick. So very much built seasonal calving, built around the hump, if you like, of feed coming from pasture, which is providing about 60 or 70% of these animals' diets. So our calving systems are relatively simple and straightforward. Here are two calving areas. The one up on the left-hand side is a bit fancier. It's called a calving pad. This is the place where cows would congregate. They're fenced into this area. They would stay in there until they calved. They would be on a special diet to help them overcome low blood calcium around the calving period. The farm on the lower right-hand side is a little bit more rudimentary, but a similar principle applies. So designated areas, cows calve, and then they join the milking herd.
Those were in Victoria?
These are both in Victoria. In fact, they're down the road from where I live. Yeah. When our calves are born, most of the time they are reared in sheds that are used for other purposes during the year. So these are not purpose-designed facilities. These are facilities that have multiple functions. Our calves generally are reared in batches. So that can be quite different to what you might have seen in the US, and I'll show you a photo of that in a tick. So here's a pretty typical dairy herd. This is a herd that's in mid-lactation. You can see, hopefully you can see reasonably well, we've got a reasonable amount of pasture sitting there. This photo was taken during the winter. These cows are essentially eating the grass as it's growing during this time of the year. The farmers are always looking for ways to try and keep a feed bank of pasture ahead of them. And one of the things that's very important in our dairy industry is we have to conserve feed during the surplus. So we have to make both hay and silage predominantly out of pasture. So this is excess pasture that's being turned into silage early on in the spring or mid-spring, or hay going into the summer. This stuff is literally coarse gold, if I can use that term. Farmers are very careful about how they store it, for the most part. They try and make a lot of it because it literally constitutes about 20% of these cows' diets. So it's a really important thing. And mostly it's fed in what you would describe here in America as pretty low-tech feeding systems. So as you can see, here's a self-serve bain-marie. Do you use bain-maries in America? You have so many words that confuse me. And apparently I to you as well. So imagine the place when you go to the cafeteria down at anywhere on the UW. and you're scooping out your peas and you're scooping out your chicken, etc., etc. Well, that's the cow equivalent in Australia. They're still hunting for the peas, of course. We do have feed systems as well in most of our dairy parlours, so most of our milking parlours. The vast majority of Australian cows get fed some sort of grain when they come in to be milked. And to give you a sense of how much they might be fed, some cows would be being fed up to 10 pounds per day. Up to 10 pounds per day, split across 2 meals, morning milking and evening milking. The lower left-hand image is a pretty fancy looking silage clamp or silage stack. This farm has spent a fair bit of money on this. I can tell because it's neat. It's been pulled off with forks on the front of a tractor. A lot of people don't do their silage this way. They do it in round bales and they cover it in plastic to help it in sile. So there's some of the different feeding systems that we've got. And remember where we started. The lactation is pretty simple. They calve and you only have to work out how you're going to feed them, how are you going to milk them, and in what groups they're going to calve. And that's dairying. Okay, and finally, during the summer, finding green things for them to eat is really challenging. So what we tend to do in our country, and the Kiwis do this as well, is we feed what is called Brassica Crops. Let's see, turnips, rape are two of the more common plants. So these are brassicas. They grow in the summer as long as they get a little bit of water. They're quite a fibrous-y, reasonable source of protein for these cows. And this is pretty classic. You grow them in a paddock or a field, you put a hot wire or an electric fence, you give them a certain break of this feed each day, and you just keep progressing down the pasture. So this is to juxtapose, these two photos were taken in virtually the same spot. It's only the camera was swung in a different direction. The photograph on the lower right-hand side was taken during the winter. I can tell that because you can see the marking of the paddocks where the cows have been eating and they've broken it up. The photo on the left-hand side was taken during the middle of the summer. So that was taken in February, so just spin it around. The month we've just gone through. Essentially, it's the equivalent of August. And you'll notice that these cows are looking for shade. The reason they're looking for shade is because the day this photograph was taken, let me do the conversion, it was 97. And most dairy cows don't like it very much when you get much above 75 or 70 because they're not designed for those sort of climates. So being able to manage heat stress in Australia is a pretty big deal. It doesn't matter where you live. Most of the time it's low tech, it's trees, some shade shelters. But it just tries to give you a sense that the feed base that these animals are eating changes a lot during the course of the year. This is not one of these things where the TV dinner is the same every night. These animals are seeing quite a vastly different diet as they go through the lactation. And one of the things that's challenging for us is that a cow's rumen is not designed for that. It likes constant sorrow. You know what I mean? It likes a constant meal. And so these cows have to do some rumen adaptation as they go through. Okay, so let's move on to milking cows in Australia. And as it turns out, milking cows in Australia looks suspiciously like milking cows in America. This is, however, an unusual parlour for our part of the world, and it's unusual because the milking machines are on both sides of the parlour. So this is what we would call a double up at home. This is very common in the United States, not so common in Australia. For the most part in Australia, the milking machines hang down the middle of the walkway, and the machines are either swung to the left or they're swung to the right. So that's a classic double up for America, relatively uncommon for Australia.
Is all the milking technology, is that made in Australia now?
So the question was, is all the milking technology made in Australia? And I'll come to that a little bit further on. Okay, now what's very uncommon in the United States, or at least in my experience here anyway, is the rotary that you can see on the right-hand side. So this is a rotary platform the cows walk on. It's a turntable. It's going around, depending on which hemisphere you're in. That's a joke. So this rotary you can see in front of you does two things. It enables the cows to be milked, It also enables the cows to be fed because you can see some feeding stalls there in the front. And again, they're getting fed 6 or 7 or 8 pounds per day. But one of the really nice things about rotary parlours, why they're very common in Australia now, is because you can milk cows quickly. This parlour will milk 220 to 240 cows per hour. It's very efficient with labour. You need 2 people to run this parlour. And the other thing is that they're relatively cost efficient to put in. So what you want to do, if you're milking cows on pasture, of course you don't want them standing off the pasture for too long. You want them to get in and be milked and then leave and go and have a feed. But the problem is that Australian cows have to walk from the pasture to the parlour, and that could be half a mile, 2 miles, twice a day. So these animals are walking a fair way. If they're walking, they're consuming energy and they're not eating. So therefore, milking them quickly becomes important. Okay, so just to juxtapose, we are now back in Wisconsin. So these are photographs that I've taken in the course of my work here. These are classic freestall parlours in this part of the world. So the cows are essentially living in these areas for most of the year, certainly for most of their lactation. Here's quite a large freestall parlour. One of the really interesting things from my point of view is that the amount of money that American dairymen, dairy women have to spend on infrastructure here to house animals is quite significant. Now, we don't have that at home, but we also don't have 6 inches of snow or 7 inches or 70 inches per annum. So in one sense, we have to deal with the hot summers, but our winters are far more benign. Now, I wouldn't have said that before I came here to live, but I'm absolutely saying it now. Thought I was going to die the first month I was here in February. So here's 2 American parlours. The one on the right is actually the parlour that the university owns in Arlington. The one on the left was a parlour that we were involved with some research. So these are classic parlours for the United States. Relatively well mechanised, have the ability to remove the teat cups automatically, so the humans are putting them on, the machines are coming off automatically. So Wisconsin and Australian dairies look quite similar, but there's a lot more rotaries in Australia. Okay, so just to finish up, this is the second part of the story, okay? One of the things that's really apparent to me coming here to work is how much your cows are like Ferraris crossed with Porsches out of a Lamborghini. So these cows are doing a lot of milk. You've got cows here that are doing 100 pounds of milk a day. So just think about that for a tick. 100 pounds of milk coming out of their 4 teats a day. And what will even scare you even more is for every pound of milk, there is 400 pounds of blood that has gone through the udder to make a pound of milk. So these things are high performance racing machines. Massive amounts of milk coming out of these animals. And it's a lot less in Australia. It's about half. And that's fundamentally because these animals are on pasture, they're foraging. We just can't get the feed matter into them. However, one thing is for sure. The people who are involved in dairying, whether it's in Australia or the United States, these people, as near as I can tell, are pretty much the same. So here's a crew from a farm that we did some research on in Australia. This is a 500 cow farm. This is how many people it takes to run a 500 cow farm in Australia. So very, very typical Australian dairy farmers. Has everyone got that? Typical Australian dairy farmers. Now I just want to explode a myth right now. The average Australian dairy farmer does not look like this guy. So I want to make that perfectly clear. This, however, is what the average Australian cattle veterinarian looks like. So well done us. One of the things that is also common in Australia is, and this has been nice coming here and working as well, is we have the same infrastructure of service providers in the dairy industry at home. So people who are involved in herd improvement, veterinarians, nutritionists. It's the same sort of set of players that sit outside these farmers, the same sort of networks. The only thing that I would say is though that we just have a lot less people in the zoo. So we have less farmers, we have less service providers. Most of the cattle vets in Australia I know by name. So that gives you a sense of how big the place is. Okay, now I just want to finish off this second part. I just want to inject a little bit of reality into the conversation. One of the things that is preoccupying me at the moment is I finish in 3 months, and currently I'm looking for a gig. Anyone? And one of the things that has become very clear to me is how perilous is the wrong word, but how fragile dairying is in some parts of the world at the moment. And the reason is, if you're a dairying country that is exporting most of your milk, Australia, New Zealand, 2 classic examples, you are absolutely exposed to the world trade price, mostly in milk powders, okay? Because that's how a lot of the stuff is shipped around the world. It's dried into powder and then it's shipped. And I wanted to show you this because the milk price in Australia has absolutely collapsed. Currently, it is below the cost of production, let alone the cost of production and then covering your interest costs. So if you're an average dairy farmer at home and you might owe the bank $1 million, the average Kiwi dairy farmer owes a bit more than that. At the moment, you can't even pay your operating costs. You certainly can't pay the bank the interest. And the reason is this. Here is the world price for skim milk powder from 2011 through to 2016. So this is in Australian dollars. Yes, it's in Australian dollars. Look at the volatility. So the scale goes from 1,000 up to 5,500. So if that's not a roller coaster, I don't know what is. And this is how farmers are getting paid. It's based on essentially the world price for what is being traded overseas. So at the moment, dairying is a difficult industry to be in. And I don't want to sort of bring it down into this, but I just want to inject a little bit of reality about what the current situation looks like. Now, of course, it will bounce back, but it's a volatile, hard industry to be in, and the people who are in it have to be smart operators. It's just that simple. Okay, now, let's liven the mood up a fraction. The tulips. I just want to pause for a minute and tell you that when you come from a country with no tulips in it, the tulips here are pretty bloody good. So every year when the tulips pop up, I walk down the road from where I work and I take a photo of the tulips and I spend a quiet 10 minutes there just enjoying the flowers, basically. Okay, so now we are segueing back into the UW, and I want to tell you a story about UW milk harvesting research, and eventually we're going to cross back to Australia. Back in 1992, there's a fellow, and I'm about to show you his photo. He established the milking lab here in the UW. Now, it's based in the biological systems engineering or the ag engineering lab, which sits opposite animal science. It's a lab that was originally funded under a cooperative program by virtually every dairying company in the US and in Europe. There are three milking labs left in the world. There used to be a lot more, but now there's only 3. There's the UW, there's one at the University of Bern in Switzerland, and there's one that's just restarting at Moore Park Research Institute in Ireland. So this is a science that has waxed and waned, but at the moment we're on a bit of an uphill climb. We've got a bit of momentum going at the moment. So the UW Milking Instruction Lab, Research and Instruction Lab, everyone who is involved with this university should be very proud of this little gem that sits in the middle of the campus, just next to the dairy farm that also sits in the middle of the campus. I want to point out the good-looking fellow who looks like he's just dropped out of an Amish commune on the upper left-hand side. That's Graham Mean. He comes from Melbourne, Australia. He's one of the best milking machine scientists in the world. He started the lab here at the UW. He worked here for 10 years, from 1990 to 2000. The reason why I wanted to put this photo up, my boss is Doug Reinemann, who is third from the left in the front row, wearing the blue gloves. Thank God he's wearing the blue gloves because no one else is. So Doug is my PI, my boss. The reason why I wanted to show you this photo is that all of the people in this photo represent essentially five countries. 5 countries. These are all people who've been involved with research here. This was part of a research project we ran last year. The milking machine or milk harvesting research fraternity is relatively small. We all tend to know each other, and there's a lot of communal effort, is what I'm trying to say to you.
Which is the Irishman?
The Irish guy, John Upton, is the guy on the right-hand side. Yeah, a good operator. Okay, so milk harvesting research at the UW in 10 minutes. Here we go. There are 3 things you want to do when you milk a cow. Ideally, you want to milk her quickly, you want to milk her gently, and you want to milk her completely. Now, I'm going to argue with you, I'm going to argue that the 2 on the left-hand side with speed and gentleness on the teat tissue, they are the big players. The completely is a bit of an evolving story. It's a bit of an older story, not so important anymore, in my opinion. So there are 3 aims. The first 2 aims are the most important. And here is the fundamentals, the physics of how milk comes out of a cow when you milk her with a machine. So here's a teat. The big P stands for higher pressure. The small p stands for lower pressure. Here is a milking liner right here. It's attached to vacuum or low pressure here. The teat goes in the top, like so. So you've got lower pressure under the teat, higher pressure inside the teat where the milk is sitting. So it's exactly the same as a weather system. It's exactly the same as how a plane lifts off, thanks to Mr. Bernoulli. It's exactly the same. Gases and fluids like to go from high pressure to low pressure. So here we go. Here we are. So the milk is flowing from high pressure to low pressure because you have put a vacuum underneath the teat. And one of the other things that happens, if we were sitting here 25 years ago, you'd be saying, oh, the teat canal that the milk comes through is a hole and the hole gets stretched. No, that's not the way it works at all. It's a piece of folded skin and it unfolds under vacuum. So what happens is it's folded, it's interfolated, if you like. I can't do it with my fingers like that. And then under vacuum, it opens up to a hole that's about 2 millimetres across. I'm sorry, I can't do that in inches, but it's 2 millimetres across. So it unfolds during milking because of the forces of lower pressure and higher pressure inside the teat. And that's how essentially cows get milked. And one of the things which is really cool about the cow's teat canal, which is a piece of skin, it's 1 inch worth of skin. So 4 teats, she's got 4 teat canals. This skin is the most specialised skin on a cow. It's a bit like taking a piece of bread and putting some butter on it and then sprinkling it with some sort of sugary condiment. Do people have hundreds and thousands in this country? Yeah, okay, so imagine hundreds and thousands on a piece of buttery bread. So the skin is leaving as the cow is being milked because it's got keratin in it. And as it's leaving during the process of milking, it's taking some of the bacteria that happen to reside in the teacup, it's taking that bacteria away. So highly specialised skin, constantly producing keratin and then shedding it during the milking process. It's a beautiful, magnificent, protective mechanism for the cow's teats. But one of the other things that happens during the process of putting vacuum underneath the teat is not only do you bring milk down, but you're also taking blood down to the end of the teat as well. And we don't want that to occur because it's like belting your thumb with a hammer. You don't want the teat to become engorged with blood. So there has to be a way of moving the blood around. And this is the way it works. So here is 3 X-rays of 3 liners. The important dimensions of the liner are the opening at the top, the size of the mouthpiece, which is this part just here, and the width of the bore of the liner. They're the 3 important dimensions. To give you a sense of how different these things are, there's about 100 different liners on the American market. There's about 80 on the Australian market. Is there any difference between these 2 puppies other than the colour? Do they look different? Well, they look different because they are. Yeah. Okay. So silicon, rubber, narrower bore, wider bore, bigger hole at the top, smaller hole at the top, a bit more tapered, not so tapered. All of this comes about because of different sort of design philosophies, etc. So one of the things that we're fundamentally interested in is how these things behave, because for the most part, it's been trial and error, not science. One of the other things to consider is that the 4 teats have a milk curve which is different. So these are 4 independent quarters milking through 4 teats, and these quarters are not all doing the same thing. So some quarters milk out quickly, some quarters don't. Sometimes they're relatively the same, other times they are vastly different. And we have to account for that in the way that we milk these cows. So essentially what happens is, here's the invention that was invented literally in 1890, the twin-chambered teat cup, the pulsation cup, the pulsation chamber and the teat cup, and here's the liner. One goes into the udder, into the other. Freudian slip, Freudian slip. That won't happen again. And what happens when you mount this, it creates a seal inside here. You've got a chamber between the outside of the liner and the inside of the shell that you can either put atmosphere into or vacuum. And what it does, by creating a pressure difference in that pulsation chamber, it's either open and milk is flowing, or it's closed like this, squeezing, and what you're doing is milk is not flowing, but blood is circulating back through the teat. Okay, so this is pulsation. 60 times a minute, open, closed, open, closed, open, closed, open, closed, and so on. So that's pulsation. And it's that action of compressing underneath the teat that moves the blood.
Do the threads have a reason?
The question is, do the threads have a reason? Not much. Not much of a reason. Well, certainly not one that I want to go into now, if you don't mind. Okay, so one of the mysteries of liners is how much compression do they put on the teat when they collapse, like this? How much compression do they put? And there's a fundamental principle that I want to show you. The last time I did this, people looked at me like I was strange, but there you go. This milking liner is made of a piece of rubber that's about 2.5 millimetres thick. Imagine if this was not made like that. Imagine if it was an infinitely thin piece of rubber. Infinitely thin. If you put a pressure difference across the bottom, it doesn't apply much force to the teat. So it's a bit like doing this. Piece of paper. Imagine my head's a teat. Just roll with me. Okay? So I'm doing this, and there's not much force. Infinitely thin, so even though I'm pulling it down, not much force. A bad hair day perhaps, but not much force. Take something that's thicker, like a milking machine liner, and you do this, and all of a sudden you've got more force. So the pressure difference is wrapping the bottom of the liner, and it's actually helping to compress the tissue and shift the blood back up. Does that make sense? Excellent. If you can get liner compression, then we're home. We're absolutely home. And this is one thing that which has been really difficult for us to work with, because still to this day, even though we've been milking cows with these devices, there is no way of directly measuring liner compression. So we work with proxy measurements, and we're trying to make those better. That's some of our research here, but there's no direct way of measuring it. Why is it important? It's important because it directly influences things like milking speed and the gentleness of milking. Okay, so milking gently. We are trying to do things like circulate the blood, remove a bit of keratin with the milk out of the teat canal, but not too much. And we're also trying to make sure that we keep skin integrity intact. We don't want to damage the outside of the teat skin with the action of milking. And one of the things that we're fundamentally interested in is, can we use the opening of the teat canal to tell us how quickly the animal's being milked and how gently she's being milked? And one of the really nice things about the physics that we work with is the size of the opening of the teat canal is simply a matter of what's the pressure difference underneath and how much milk is flowing through it. If you can measure those two things accurately, you can work out the size of the unfolded teat canal. And you can therefore work out how much congestion is there. So for example, on the left-hand side here, as we increase vacuum, the teat canal starts to unfold. It reaches its maximum elasticity or degree to unfold. And if it starts getting smaller as we apply more vacuum, it's because the teat is becoming congested. And we don't want that. We want to be able to predict that and go to that point, but not go into congestion, because therefore we will interfere with milking speed because we make the teat canal smaller. So one of the things that we've got here at the UW, there's only 2 of these in the world. This device was invented here. It's called the MI4. It's a quarter milking device that allows us to set the milking condition to all sorts of different conditions of milking for vacuum and pulsation. And we can change the milking condition every 10 seconds, essentially. So we can milk a cow 20 different ways in one milking. This is a fundamental leap for milk harvesting research anywhere in the world. It was invented here, it was invented by my boss, and it's a really, really handy device. And it's absolutely jet propelled some of the work that we've been doing here in the last 3 years. Just to show you one brief outcome of an experiment. This is where we have taken a liner and we've either put high vacuum in the mouthpiece to try and congest the teat barrel, or low vacuum there, or we've put high or low vacuum underneath the teat end. And what we're trying to see is if you congest the teat barrel but not try and congest the teat end, what does it do to the teat end? And one of the revelations in the last 12 months for us has been that if you congest the teat barrel, this part here, you're actually congesting the teat end a lot more than what we thought. And we just didn't know this before because we weren't able to accurately measure milk flow in the way we've been able to do it now. So very, very interesting and important work from our perspective, because now when we start to assess the performance of liners, we are putting in the vacuum levels in the mouthpiece into our models, which help us to much better predict what the performance of the liner is going to do. I want to show you a few ultrasound images from the milking research. So this was the same experiment. We're trying to congest the teats as part of this design. So here's a normal teat. I hope you can see that image okay. This was taken by our friends in the vet school. So that's a normal looking teat. If you congest the end of the teat, this is what it looks like. So what you're looking for is blackness in the image, essentially, which is fluid. Okay, so normal teat, congested at the end. If you congest the barrel, it looks like this. See the congestion in the barrel? So that's congestion up around here because of high mouthpiece chamber vacuum. And if you congest all of the teat, the barrel and the teat end, you get a vastly different looking teat. So this is a teat that is not being milked gently. This is a teat that's not being milked quickly because there's so much congestion, it's decreasing the size of the teat canal. And this is pretty important work for us. This is foundational work for us. Okay, now I just want to finish off with one final bit of the puzzle and then we're going to stop. One of the things that we can do with that MI4 machine that I showed you is on the vertical axis we've got vacuum, going from lower vacuum to high vacuum. And on the horizontal axis we've got pulsation ratio, where on the left-hand side the liner is spending an equal amount of time closed and opened, but on the right-hand side it's spending a lot more time open than closed in the massage phase. So this allows us to put in all sorts of different milking permutations and combinations of vacuum and pulsation to see how the teats will respond. And if you can measure the milk flow really accurately, you can produce this, which is a liner map. So the way this map works is as you increase vacuum, which farmers can do, the teats will milk quicker to a point where they start to congest. And if you alter the pulsation so that the teats spend more time, the liner spends more time open, they will milk quicker, but you also have the risk of congesting the teats as well. So this is like a topographical map It's trying to say, as you change on the farm the conditions of vacuum and pulsation, yes, you are going to milk quicker, but at some point, congestion starts to encroach on the milking experience of the cow. And one of the things which I didn't put into tonight because it's just a bit fiddly to explain is, along with the milking speed maps for these liners, there's also congestion maps. And we, I think, should be pretty proud of ourselves here at the UW because this approach of assessing liners and mapping liners and describing their performance was essentially invented here. I think it's very useful for the dairy industry going forward. Okay, so what does the future look like? The future looks like this. This is a robotic milking unit. There is now about 30,000 of these boxes in the world. It's the equivalent of every cow in Australia being milked by one of these. These are essentially quarter milking devices. And here's what the future looks like for milk harvesting. The future looks like a tailored experience for your cow's teats. So here I am. I'm Betsy. Let's see if I can do this. This could be dangerous for television. Okay, so here's Betsy's 4 teats. And the future looks something like this. Through the process of milking her for the first couple of weeks, we decide that this teat here likes a different milking condition to this teat here, and these two at the back like the same. So Betsy's teats get a tailored milking experience based on the first couple of weeks of milking her. And we keep reassessing that through the lactation. So this is essentially what the future of milking is going to look like. It means a quick milking but a gentle milking for this animal. And that's probably where we're going to end up. Okay, and with that, the final piece of the puzzle. What does research in milk harvesting in Wisconsin, is it transportable? And the answer is yes. Unlike some parts of dairy research, the way we milk cows mechanically around the world is the same. So it doesn't matter whether we're talking about milk harvesting in Ireland or New Zealand or Australia or in Wisconsin or, God help us, in California. It's all the same mechanics and physics and tissue. And that's a really good thing. So very, very transportable research. And with that, I'd just like to acknowledge the sponsors of our lab, Avon, Dairy Australia and Chuggas. Does anyone know the name of the most famous cow in rock history? No one? So this is Atom Heart Mother. She's a cow from the 1970s, the most famous cow in rock. If nothing else, can you please remember her name for the end of this presentation? And finally, I just want to leave you with this. If you had to take a guess, being an Australian coming into Wisconsin, of what sort of things Americans like to say to you, what would your guess be?
That's not a knife.
So someone has said, that's not a knife. Anything else? Any other takers? How about something like, hey John, throw another shrimp on the barbie. So the two most common things that Americans say to Australians, like me, are this. That's not a knife, this is a knife. Or, hey, throw another shrimp on the barbie. Ironically, both said by the same bloke, Paul Hogan, on the left in an ad for Australian tourism in the 1970s, on the right as some bloke called Crocodile Dundee. So there we go. Famous words uttered by one man who was pretending the whole time. Folks, thanks very much for listening. I really appreciate it. Thank you very much.
Questions?
Do you mind if I take the person up the back first?
Yeah.
You didn't mention breed of cows.
In Australia?
And I noticed it looked like there were Holsteins, Guernsey, and some handfuls of brown Swiss.
Yeah.
But does one breed of cow do any better down there than versus here?
Yeah, so the question is about breed of cow. What are the breeds of cow in Australia, and do some do better than others? It's a really good question. So here's the answer in a nutshell. Back when Australian dairying was in its formative years in the 1950s, there were a lot less black and whites in our country. So mostly they were Jerseys Guernseys. There's a breed called the Australian Illawarra Red. So these are multi-purpose breeds. You can milk them. In some cases, you can use them for meat as well. And what's happened since the inception, if you like, of artificial breeding, what's happened is the world genetic pool has basically gotten smaller. So as production has been emphasised in both pasture systems and other parts of the world not using pasture, the Holstein has become the dominant animal. The Friesian Holstein has become the dominant animal. And with the movement of semen around the world, what's happened is that the Holstein Friesian is now the dominant animal in Australia by an absolute country mile. We have a ton of North American genetics in our herd, North American and Canadian genetics. I used to work with farmers at home. They would only buy genetics from Canada or only buy genetics from ABS, which is based up the road in Wanakee. The black and white cow, very, very, very popular because, you know, reasonable milk components, butter, fat and protein. They milk like trains. The only thing is, freight trains, the only thing is that these animals are less heat tolerant than Jerseys and Guernseys. So, you know, you have to pay the piper somewhere. So you have to be a bit more careful with heat stress with these animals. But if I was to describe the numbers, 70% of the Australian herd is very close to purebred black and white. Really good question. Did I answer it okay? Excellent. Yes?
Yeah, I was going to ask, you mentioned heat stress. Does the fact of the climate variations, does that have any effect on dairy products or practices in Australia? I'm thinking of Queensland, where it's almost tropical in some areas.
Yeah. So the question is, with the climate variation up and down our country, are there changes in the way dairy products can be produced, or are there changes in the way the production system works? The fundamental answer is, I'm going to hedge my bets here. The product mix that they make from the milk is pretty much the same, but what tends to happen is that they have to be far more careful in the northern part of our country. So once you get into northern New South Wales up into Queensland, what tends to happen is those farms will tend to try and have cows calving all year round. And the reason why they do that is because predominantly, certainly historically anyway, their milk is going into liquid milk. So it's going into supermarkets. Most of the milk that was going into cheese, going into powders, going into butter, etc., is coming out of the southern end of the country where there's less climatic variation. Fundamentally, it is harder to milk a cow the closer you get to the equator. The irony in all of this, here's a historical fact that you'll never trot out to any of your friends at the pub over cheese curds and a spotted cow. But ironically, Queensland, the hottest place in our country, was the place that had the most dairy cows in the 1970s. So, you know, you get these little quirks of history. But fundamentally, the production system is different because of the way they set up the calving, and where the product is going is slightly different as well. Good question. Yes, up the back.
Will you comment on Wisconsin and Australia's science understanding of stray voltage in the dairy industry?
Yeah, sure. Okay, so the question is about the science that looks at a phenomenon called stray voltage, both here and in Australia. So as it turns out, the stray voltage guru of the world lives here. He's my boss. Oh, stray voltage, okay. Sorry. Sometimes I get ahead of myself, according to my wife. So stray voltage goes something like this. You've built a dairy, you've built a parlour, but you haven't earthed it correctly. So the idea fundamentally is that the cows, when they come in to be milked, and you switch on the milking unit, so you've got more current running through the line servicing the various parts of the plant that are operating. The cows can get in contact with that, and it can interrupt their milking experience because essentially they're getting a low-grade shock during the milking. So here's the problem though. Here's the problem. Stray voltage has been blamed for everything from the dog ate my homework through to these cows aren't milking enough compared to what I think they should be. And so whenever people mention stray voltage, there is now a very, very tightly prescribed checklist that you go through to try and determine whether that is indeed the problem. Because one of the things that never gets talked about is the fact that cows are high impedance. It's not that easy to get a current to go through a cow. So, you know, I've seen people who should have known better in Australia taking oscilloscopes out to farms and getting a waveform, and of course it meant nothing. So the science of stray voltage has been absolutely bolted down. The person who did most of the bolting down is here, my boss Doug Roneman, and for the most part, if people are claiming it to be a problem, unless you've gone through those very prescribed investigative steps, it's something that I don't lose any sleep over. Did that answer the question?
Well, I guess, is it as bad there as it is in Wisconsin in terms of public education?
That's a really good question. So the question is it as bad in Australia in public education around stray voltage as what is it in Wisconsin? Let me answer the question by saying that the last time someone did a public forum in Australia on stray voltage was 1998. I know this because it was the day I met my boss for the first time. He was in Australia talking about it. There's been a little bit of talk about it in New Zealand in 2012. To be honest, not many people worry about it anymore. It was one of those things that went through a big wave of, oh, we've got stray voltage, that's why they're not milking very well, and the wife hates me, through to, and that sort of, that wave went. That wave went. Good question. Yes?
In some places in Wisconsin, we also do some more with cows in pasture, and I'm just wondering, is it mostly the climate or the soil that determines what makes the most sense to do?
Okay, so the question is, there are some places in Wisconsin that have some sort of pasture base, and what is it about the farm's situational topography that determines whether they can use pasture or not? My understanding of farms that are using pasture in Wisconsin is a lot of the farms are running organic operations, and there are prescribed periods where they have to be on pasture for certain times of the year. A lot of it comes back to essentially how much land you've got, how well can you grow pasture, and how well can you utilise it, and for how many months of the year. So you can pasture cows in this part of the world, and you can do it relatively well, but you can't do it for 4 or 5 months of the year because it's just too cold and nothing's growing anyway. So one of the advantages that we've got is whilst we have 4 or 5 months of the year where not much is growing, or 4 months of the year, we don't have the climatic extremes of cold to deal with. So we can conserve the fodder and feed it out during the summer. Whereas here it just makes more sense to bring the cows inside. And I think what's happened over years, and I'm no expert on this at all, but my perception of certainly dairying in Ireland and in England, where I've got a lot more experience, is that over time the cows have just ended up spending more and more and more time inside because the management of those animals became simpler. Simple as that. But you can certainly pasture cows in this part of the world, and lots of farms do it. There's about 300 organic dairy farms in the state, I think, or even more, and all of them are using pasture to a greater or lesser degree. Good question. Yes?
Do you think that the butter, you described it as having what I call it 4 watersheds or 4 different supplies, would change its performance with the smart milking machine? In other words, if you say, okay, we're looking at quadrant 1, if we optimize the tissue mechanics here, will we wind up getting over a week, or a month, or however long it takes cow to adjust, more milk production out of that quarter?
Yeah, okay, so that's, are there any easy questions in my future?
That's where you go with something like a smart milker.
Yeah, that's right. So the question is about, because you've got four quarters that are all essentially acting locally, mostly due to endocrine or paracrine influences, and there's a whole science around this. But the question is, if you milk those quarters individually, do you start optimising their production? And we think the answer to that is yes. We've been running some experiments this year. Now, we did something which sounds daft, right? We under-milked 2 quarters and we milked completely the other 2. And what we were trying to do is we were trying to see how far we could take under-milking before the production rate in milk between milkings dropped off. In much the same way that we fundamentally know if you take a cow that's milking twice a day, in the morning and at night, and then you milk her 4 times a day, bang, 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 and they don't even have to be equally spaced. We know that we can shift the production rate in between milkings by about 15% and then by about another 7%. And that's a function of the fact that we're removing the milk more often. So if we can find the sweet spot between milking frequency and the amount of milk to remove, along with milking speed, then we think we can help to optimise production rate per hour. And these gains are they're not likely to be that small. We're not talking 0.5%. We're talking more than that. We're talking 3, 4, 5, maybe 10%. So there's a fair prize on the table, and the technology is already there to do it. That's the thing.
There's a boost for Wisconsin technology in the future. We can build machines that will do that for you.
Yeah, so the question is, well, the comment is there's a boost for Wisconsin technology that can do this. The answer is yes. If you look at the technology that's wrapped up in the common automatic milking machines or milking robots, the Lely robot, the DeLaval robot, just to name the 2 more common ones, these machines are inching towards that type of capability, provided we can get the fundamental science right that should underpin that. Because it's not just a matter of build it and they shall come. We've got to build it and know how it's going to work, and then they shall come. Yep. Any other questions? Yes?
What are the primary countries of destination for the export of Australian dairy products?
Okay, so the question is, where does most of our stuff being sent overseas go? China, and China. Japan, Southeast Asia. We export a little bit into the EU, but not much. We send a little bit to the States, but not much. Most of our milk is heading into Southeast Asia. A bit of it's heading into India as well, but India is rapidly growing. Our country got very excited a couple of months back. We signed a free trade agreement with China, so cause for vast celebrations. But unfortunately, here's the reality. The milk price traded internationally tracks the oil price. Simple as that. It's 6 months behind, or it's give or take. But essentially, if oil is not worth that much money, then the commodity of milk traded internationally is not worth that much money either. So that was explained to me by a German agricultural economist one day, and I can't remember the reasons. But he swore, I mean, this is a guy who's one of the gurus of world milk price volatility. This guy's got a reputation as long as your arm. And it's a long arm. I mean, that was his opening gambit. When oil starts to come back up, so too will dairy. John?
Wouldn't the ultimate system on a robotic machine to actually have some, some instantaneous feedback on how the milking apparatus is going, on the milk control is flowing, where you have computerized feedback on how things are working in real time? Yeah. So the question is, would it make sense to have instantaneous feedback on a milking robot? The fundamental answer is no. And here's the reason why. I'll just show you this quickly if I can find it. Here's the reason why. You all wanted to see Crocodile Dundee again. Here we go. Okay. Here's the reason why. So this is a milk curve that deliberately hasn't had its milk let down at the front end. So don't worry about the front end of the curve. Just look at the main part of the curve. Most milk flows go up to the peak, and they'll go up to the peak within 30 seconds. Then they basically sit at the peak.
The peak will last for 2 minutes, 3 minutes, etc. That band that they're in the peak is plus or minus 10%, give or take. To be perfectly frank, it doesn't really matter that we can control things in here. What matters though is how we measure flow, and if we manipulate the milking slightly by altering the vacuum, measure the difference in flow, and if we do that a couple of times over a number of milkings, then we find the sweet spot for that teat. Because one of the things that I didn't say to you is that if you measure liner compression with this puppy, you have to use something like 20 teats to do it, to get an average, but the 20 teats are all acting like individuals for the liner compression. So it's within a band, but it's not like saying, John, here's a rubber boot for you. They're all size 8s. And everyone in this room is going to wear a size 8 and you're going to enjoy it. Because as it turns out, the amount of compression that size 8 is putting on you is going to alter a little bit. So what's happening up here in the peak during an individual milking is not of huge importance. What is of importance is gathering the information to optimise the longer term milking for that teat. Good question. Yes?
How do the different Australian states and territories rank in terms of milk production?
So the question is, how do the Australian territories and states rank in terms of milk production? Let me give this to you quickly. Tom, how are we going for time?
You're doing great.
Okay. You wanted to see Crocodile Dundee again, I know that.
Of course.
Okay, so Victoria, let me give it to you in farms. Western Australia, 150 farms. Tasmania, about 400 farms. South Australia, here, about 400 farms. The vast majority of farms are in Victoria, 5,000, something like that. There's about 400 farms in New South Wales. There's about the similar amount in Queensland, about 400 farms. Now, I might have got those numbers not quite right, but the proportions are right. Literally, about 70% of the milk for our country comes out of Victoria, or that band that crosses the Murray River, just up in here, because it's all the one dairying area. Yeah, good question. Most of the milk comes from south. Why would that be the case? You can tell me. Pasture production, and it's cooler. The cows are happier. The closer they get to Antarctic, the happier they are. Good question. Any other questions, comments? I wish the redhead would shut up.
Thank you very much.